Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mayim Akhtar and I am from the Department of BS Chemistry. My ID is 004 and this is the course of Organic Chemistry. And the assignment that was given to me was of alkane. So first of all, we should know that what is homologous series. Homologous series is basically the families of the organic compounds. These are known as homologous series. And homologous series is the family of compound with the same general formula, same functional group, and similar chemical properties. Now moving towards the characteristics of the homologous series. As we know that it has same general formula, it has same functional formula, it has same chemical properties that always vary in reactivity, and its physical properties also vary with the series. There are homologous series of alkanes, alcohols, alkenes, and carboxylic acids. These are the examples of the homologous series. Then we should know about the functional group. Functional group is basically an atom or a group of atoms that imparts its characteristics when it is combined with a particular compound. Alkane, this is the examples of the homologous series. This is alkane and this is the example ethane. Functional group, there is no functional group in alkane because the single bond isn't considered in the functional group. This is the general formula of alkane. This is the alkene. Examples, functional group. This similarly we have alcohols and carboxylic acid. Now, what we do when we are going to name a compound? When we are going to name a compound, we should divide it into the two parts. The first consists of prefix and the second consists of suffix. In the first part, we can see the example meth, eth, prop, and but. In the second part, suffix, we can see the example in the alkanes, in the alkenes, alcohol, ol, oic acid, in carboxylic acid. So this is how we give the name of any organic compound with respect to this. So what is alkanes? Alkanes are the homologous series of the saturated hydrocarbon. We should know the difference between the saturated and unsaturated hydrocarbons. Saturated hydrocarbons are those which contain single bond, while on the other hand, unsaturated hydrocarbons are those which contain double or triple bond, in which saturation occurs in hydrogen bond. Each carbon are linked with the other carbon through a covalent bond. The general formula of the alkene is CnH2n plus 2. And how alkenes are represented? Its nomenclature are discussed through which it can easily be named. It has provisional name, it has common name, it has trivial name, it has IUPAC name. This is the structure of the methane. Methane shows tetrahedral structure and is the simplest alkane in the homologous series. Now, if we are going to talk about the structure and classification of the alkanes, hydrocarbons, then we'll come to know that each carbon is attached with the other carbon through a single covalent bond. They show linear as well as branched shape. It also shows isomerism. Now we're going to talk about isomerism. These are the isomers of the butane, N-butane, isobutane, cyclobutane, methyl cyclobutane. These are the isomers of the C4 carbon homologous series. So if we talk about the isomers of the carbon series, we can see that carbon 1, methane contain only one isomers, ethane contain only one, propane contain only one. Two isomers are contained by the butane, carbon 4, butane and isobutane, while in the 5 we can see the 3, so on we can see millions of isomers as the number of carbon exceeds. So this is the nomenclature through which we can easily give the name of the alkane. we have to select the longest continuous chain. Then we have to give the lowest possible number to the substituent and then to the functional group. Here we'll give the lowest possible number to the substituent, and we have selected a longest continuous chain like this, and then 1, 2, and 3. So we'll give the number 2, 2, as we have seen that there is a 2 methyl group. So we'll give it a name 2,2-dimethylpropane. As we know that it has linear as well as branch shaped. Both shape can exist in it. These are the branch structure of the alkane. We can also call it ball and stick model of the isopentane. Now moving towards the physical properties of the alkane. In physical properties, alkenes have low melting points and boiling point. And melting and boiling point depend upon the intermolecular forces. So alkenes have very weak intermolecular forces, so it has low melting point and boiling point. Alkane become very larger. Increase in the number of carbon atom, there is an increase in the attraction of the forces among the molecules. More heat energy is needed to overcome the intermolecular forces. So thus the melting and boiling point increases as the number of carbon atom increases. This is all due to the molecular attraction among the molecules. In physical states, we can see that alkenes from carbon 1 to carbon 2 are gases. For example, butane, below lamp. And from carbon 5 to carbon 17, we can see kerosene lamp are liquid. And so on up to 18 and so on, we can see it is solid. As the number of carbon atom increases, the molecules also increases. These are the properties that we are going to discuss in the physical property: melting point, boiling point, solubility, conductivity, molecular geometry, bond length and bond angles, conformation, spectrometric properties, infrared spectroscopy, NMR spectroscopy, and mass spectroscopy. In boiling point, we have seen that in organic compounds or again hydrocarbon, we come to know that the boiling it has very low boiling point because it all depend upon the intermolecular forces. As the number of carbon exceeded, the boiling point also exceeded because more heat energy is required to overcome the intermolecular forces. This is the same as I have told you earlier. The boiling point of the alkane are governed by the intermolecular forces of attraction. This is heptane, this is octane, and this is nonane. As the number of carbon increases, the boiling point also increases. And in the case of the branch chain that comes in the compound, we see that the boiling point decreases. It has merely one branch here. It has more branch, 1, 2, and 3, 4 branches over here. So the boiling point also decreases. In melting point, same order will be discussed. But what if we talk about the conductivity and the solubility? Alkanes do not conduct electricity in any way. They are not sustainable polarized by the electric field. For this reason, they have no hydrogen bond and they are not soluble in polar solvent. This is why they are non-polar, and alkanes are said to be hydrophobic because they repel water. They have lipophilicity. Because of this, they are repellent of water. The molecular geometry of the alkanes show that in methane we can see the sp3 hybridization in which 1s of the hydrogen and 3p of the carbon are hybridized together and form 4 sp3 hybridized orbitals, and we get the structure of the tetrahedral having 120 angle. This is the structure of the methane, tetrahedral structure of the methane. These are the conformation tests of the alkanes: NMR, infrared, mass spectroscopy. Alkanes have a high ionization energy and molecular ion is usually very weak. The fragmentation pattern can be difficult to interpret. So that's why the results are because of the free radical, and the fragment resulting from the loss of single methyl group is often absent. Now I'm moving toward the chemical properties of the alkane. The first property that we'll come to know is of heat of combustion. With the increasing number of the carbon atom, more oxygen is consumed, because more carbon will consume more oxygen, and more moles of carbon dioxide and the water will be formed. Alkanes are generally unreactive, that's why they are called paraffins, low reactive, because they are non-polar. This is because molecule contains single carbon-carbon covalent bond and single carbon-hydrogen bond, which are very strong and require a lot of energy to break. In the combustion, we come to know that when the alkane consumes oxygen, the sole products are carbon dioxide and water. This is highly exothermic reaction. Alkanes also go substitution reaction, in which it's replaced the atom in a molecule. And it also goes free radical mechanism. Halogenation is a process in which halogen molecule is added to the alkane. Here is example methane, and chlorine is added to the methane, in which we get chloromethane. Here hydrogen from the methane and chlorine from the chlorine molecule comes together and form hydrochloric acid, hydrogen chloride. And this is chloromethane. Again this happens and free radical mechanism starts. This is dichloromethane, this is tetrachloromethane, and this is how we get tetrachloromethane. This is the reaction of the alkane with the oxygen. Halogenation is already discussed above. The isomerism is a process in which have same structural formula but different, which has same molecular formula but different in structure formula. These are the isomers. We have already studied isomers. For example, butane has two isomers, isobutane and N-butane. So we should talk about the summary that we have studied until now. Alkanes are basically give carbon dioxide and water when it's reacted. Carbon dioxide, it is the general formula like this. It contains ane with the compound at the end, suffix. It consists of protonium as source. It is also very useful. It's for substitution reaction. These are saturated. They differ by the other atom by CH2 molecule or 12 atomic mass. Now, what are the occurrences in the universe? Methane and ethane make up the tiny portion of the Jupiter's atmosphere. Extraction of the oil, which contain many distinct hydrocarbons including alkane. So, alkanes on Earth. The traces of methane gas occurs in the Earth atmosphere produced primarily by the methogenic microorganisms such as archaea in the gut of the ruminants. This is a glucose which is broken down into methane and carbon dioxide. Now, we are going to talk about the biological occurrence of the alkane. As we know that methogenic bacteria, archaea in the gut of this cow, are responsible for some methane in the Earth's atmosphere. So this is how we can get methane from the atmosphere too. Fungi and plants. Alkane also play an important role, if a minor role, in the biology of the three eukaryotic groups of the organism: fungi, plants, and animals. Some specialized yeasts such as Candida tropica, Picha, etc. Rhodiotrella can use alkane as a source of carbon or energy. The fungus prefer the longer chain alkane in aviation fuel, and in aircraft it's also very useful. In animal, alkane are also found in animal product. Also, they are less important than unsaturated hydrocarbon. One of the example is of shark liver oil. Ecological relation of the alkanes. One example in which both plants and animals plays an important role, the ecological relationship between the sea sand bees and the earlier spider orchid, can be seen through the alkanes. Now moving towards the application. The application of the alkanes depend upon the number of the carbon atom. The first four is mainly used for the heating and cooking purposes. Methane and ethane are used for the main components of the natural gas, as 85% of the methane are present in the natural gas and rest of the gases are very minor. Propane and butane are the gases at room pressure that can be liquefied at very low pressure. Pentane to octane are highly volatile liquid. They are used in the fuel in the internal combustion engines. Alkanes from nonane to above decane are used for highly viscosity liquids. For example, it is used in gasoline. Alkanes from hectane to upwards are very important in the use of the fuel oil. Alkane with a high length, approximately 35 or more carbon, are found in bitumen used, for example, in road surfacing. And synthetic polymers such as polyethylene, polypropylene are alkanes with a chain containing millions or hundreds or thousands of carbon atoms. In the production, we can see different reaction, feature Tropsch reaction, which are used in the industries for the petroleum refining. These are the sources of alkane. Naphtha, light gasoline, refinery gas, residue gas oil, and kerosene oil are the sources of the alkane through crude oil. Petroleum refining. Cracking converts the high molecular weight hydrocarbon to more useful low molecular weight ones. Reforming increases branching of the hydrocarbon chain, increase having burning characteristics for automobile engines. Now, ethane has the following properties. Ethane has chemical formula C2H6, molar mass, appearance is colorless, and the odor is odorless. Its density is this, and melting and boiling point is this. Its solubility in water is this, and vapor pressure is 3.84. And what are the hazards of the ethane? Safety data sheets and the sample that are used are that. Now I'm going to talk about the preparation of the alkanes. Alkane can be prepared from the unsaturated hydrocarbon, alkyl halide, from Grignard reagent, from carbonyl compound, and from carbon carboxylic acid, monocarboxylic acid. And the first reaction is in which we can see that hydrogenation of the unsaturated hydrocarbons, Bettier-Sandron reaction. This is the alkane in which hydrogen is added through under our conditions, nickel catalyst and 200 to 300 degrees Celsius, and we get alkane or desired product. This is an example. This method is of industrial importance in vegetable ghee. Franklin method reaction in which the alkyl halide with zinc react and formed alkane with the zinc chloride, zinc halide. From alkyl halide zinc is react and there is a proton and halogen and we get the desired product alkane. In the third method, decarboxylation means removal of carboxyl ion from the carboxylic acid. This is the sodium salt of carboxylic acid which react with caustic soda and under the condition of quicklime calcium oxide and we get alkane. This is the Kolb's electrolytic method generated by the Kolb's through electrolysis. This is the sodium salt of carboxylic acid and it is going through the electrolysis. When it's passed through the water, we'll get alkane. In this mechanism, anode, we see the carboxylate ion which gone through the electrolysis and generate a free radical ion by releasing two electrons and undergone a homolytic cleavage. And then these free radical cleavage occur and we get two methyl and two carbon dioxide molecules. And these two radicals of the methyl group react with each other and form alkanes. And at cathode, water gains the two electrons and form the potassium hydroxide. In the fourth preparation of the alkanes, we see that from carbonyl compounds, Clemmensen reduction, in which four hydrogen, a nascent hydrogen is added to the carbonyl compound. This is a ketone and this is aldehyde, and we get alkane from both of the reaction, but the reaction conditions are changed. In Grignard reagent, water react with the Grignard reagent methyl magnesium bromide, and we get alkane. These are the summary of all the preparation method of the alkane: Wurtz reaction, Grignard reaction, recarboxylation reaction, and cold electrostatic method. In the reaction, we will see different reaction in which there is alkane which reacts and form low alkane, high alkane alkanes, oligomerization, alkane aromatization, pyrolysis, combustion, and catalytic reaction oxidation. In combustion, alkane react with excess oxygen and form carbon dioxide and water. But in the case of incomplete oxidation, we get carbon monoxide too with the coke, C, carbon. In catalytic oxidation, we have methane and it is oxidized and we'll get methyl alcohol. This is a cycle. As the methyl alcohol is oxidized, it forms formaldehyde, and when formaldehyde is oxidized, it forms formic acid. And when formic acid is oxidized, we get our desired product, sole products, carbon dioxide and water. In the seventh, there is a nitration in which nitro group is introduced into the methyl group and we get nitromethane. Methane. In halogenation, halogen group is introduced into the alkane and we get alkyl halide. This is the free radical mechanism. Free radical mechanism which has three-step: initiation, propagation, termination. In initiation reaction, we have to initiate this reaction through the free radical, and we get free radical through the homolytic cleavage of the halogen. And this is the homolytic cleavage of the chlorine, and we get two chlorine free radicals in the presence of the sunlight, and this initiator free radical attacks the methane, means alkane, and we get HCl and methyl free radical. And this is how the reaction propagates in the propagation step. And when these reaction, again the free radical attacks the methyl free radical and it forms methyl alcohol, methyl chloride. And this chlorine free radical attacks with the chlorine and form chlorine molecule, and this is how we get alkane and alkyl halide as our desired product. This is sulfonation. In this reaction, the thing that basically occurs is the replacement of the hydrogen atom of the alkane by the sulfonic acid group. This is all known as sulfonation. This is methane. This is the alkane, and under specific condition we get sulfonic. This is the sulfon. This is the sulfonation group added into the alkane. Pyrolysis is basically the thermal decomposition of the organic compound. Greek word py means fire and lysis means breakdown. Pyrolysis is basically applied to the alkane. It is called pyrolysis or cracking. Isomerization, this is the cracking in which alkanes are cracked into lower alkanes, lower hydrocarbons. Isomerization is a process in which we form different isomers of the alkanes. These are the summary of the alkane that I have discussed all about. This is the chemistry of the alkane, and this is a summary, and this is all the reaction of the alkane. This is all the reaction of the alkane. These all are the reactions. These are the chemical properties. Alkanes can react with oxygen and form sulfur carbon dioxide and water. It can react with halogen and form alkyl halide. It can react with other products and do aromatization hydrocarbon. It can react with water and in the presence of nickel and form carbon monoxide and water. It goes pyrolysis and form alkanes and alkene respective. It also go isomerization and form isomeric alkane. It can also react with water and form. Alkane can also be produced when it's react with water. Grignard reagent when react with water it form alkane. When monocarboxylic acid react with water through electrolytic methods form alkane. These are the preparation methods of the alkanes. Thank you. That all from my side.